Hello students, how are you? Hope you are doing well. Now the question is, a long straight wire of circular cross section of radius small a carries a steady current capital I. The current is uniformly distributed across its cross section. The ratio of magnitudes of the magnetic field at a point small a by 2 above the surface of wire to that of a point small a by 2 below its surface is option A 4 is to 1, option B 1 is to 1, option C 4 is to 3, and option D 3 is to 4. So the problem is based on the concept of the calculation of the magnetic field due to a current carrying wire at an outside point and at an inside point. So suppose this is a wire, a cylindrical wire carrying a current I. The radius, for example, of this wire is capital R, and from the axis of this wire there is some outside point, for example point P, which is situated at a distance of small r with respect to the axis of the wire. Then in that condition, the magnetic field, that is the outside point magnetic field, is given by mu naught upon 2 pi I upon r, I upon small r. This is the formula to calculate the magnetic field outside this particular wire, having a distance of small r from the axis of this particular wire. Similarly, for the inside point, the magnetic field is given by, suppose there is some inside point like this point, we call it as point Q, and the distance of this point Q from the axis, for example, is now in this case as small r. With the axis, the distance of the point inside this particular wire is small r. Now in that condition, the magnetic field is given by the formula mu naught upon 2 pi into I upon capital R square multiplied by small r. So this is the condition when the value of small r is less than capital R, where capital R is the radius. And the first condition is valid when the small r is greater than r, that is for the outside point. So these two formulas we have to remember to solve this particular problem. Now let us analyze this problem. So there is a wire carrying a current of I. The radius of the cross section of this particular wire is given as, this radius is given as small a. Now in the first condition there is an outside point, for example this point is P, and it is given that this particular point is at the distance of a by 2 from the surface of the wire, small a by 2 from the surface of the wire, and a is the radius of this particular wire. So in this case we can say that this is the outside point, and for the outside point, the magnetic field is given by the formula mu naught upon 2 pi. This is mu naught upon 2 pi I upon r. Now what is r here? Small r. What is small r here? Small r is the distance of this particular point P from the axis. Now from the axis to the surface is the distance a, small a, and from the surface to this point the distance is a by 2. So we can say that the total distance is small a plus a by 2, which is equal to 3a by 2. So we have to put here 3a by 2. So this comes out to be mu naught upon 2 pi 2I upon 3a. This is the magnetic field at the outside point. Call it as equation 1. Now the second case, when the point is inside the surface and the distance of this point, new point, for example, this is Q, and the distance is small a by 2 from the axis of the wire. Now in that case, B inside is equal to mu naught upon 2 pi into I upon capital R square means here in this case as a square, because the radius here in this case is small a. So a square multiplied by the distance, in this case r, small r. So small r is a by 2. Now this a cancels with this a and we get this value as mu naught upon 2 pi, and this is equal to I upon 2a. This is I upon 2a. Call it as equation number 2. Now we have to find out the ratio of the magnetic field. The ratio of the magnetic field, that is B outside upon B inside, which is equal to mu naught, the outside is mu naught upon 2 pi, 2I upon 3a, 2I upon 3a divided by b inside. B inside is mu naught upon 2 pi into I upon 2a, I upon 2a. This mu naught upon 2 pi cancels with each other. This I cancels with this I, this a cancels with this a, and this 2 goes up. So it is 2 to the 4, and this is 3. 3 into 1 is 3. So this ratio is 4 is to 3. So we can say that B naught upon Bi, that is the outside magnetic field, outside point magnetic field upon inside point magnetic field, the ratio is 4 is to 3. So 4 is to 3 ratio is option number C. So option C is correct here. So hope you understand the solution. Thank you.